one of the nice applications of radicals is finding the distance between 2 points. Finding distance between points. So I have the points A, negative 3, 4, and B, 0, 0. A is negative 3, 4, B is the origin, 0, 0. And I want to know how far apart are those points. In other words, if I draw a segment, a line segment, connecting those 2 points, what is the length of that little segment? Not the slope, the length. Now, the way that we go about this is very, very simple. It might seem complicated, but it actually isn't. If you look at this picture, you might have an idea formulating in your mind. Because this question of finding distance between points, it's not only an application of radicals, it's an application of the Pythagorean theorem. Because if I drop a line down to the x-axis, and then draw a segment over from the origin, that right there is a right triangle. This is a big deal, because now I can say, well, that's up 1, 2, 3, 4. So that has a side length of 4. And then I have 1, 2, 3. That has a side length of 3. So if x is the length of the segment that I want, it's actually just the hypotenuse of a right triangle. I can use the Pythagorean theorem for this. Super easy. I have 4 squared plus 3 squared, 4 squared plus 3 squared, equals c squared. And if you want to call it x, then whatever. It doesn't actually matter what you call it. 14 is, of course, or 4 squared is, of course, 16, plus 9 equals c squared, so I get 25 equals c squared, which means that c is equal to 5. And so this segment, then, is 5 units long. 5 inches, 5 feet, 5 meters. There's not really actually a scale, a measurement on this coordinate plane. It's just units. 5 units. Keep in mind, of course, that that's not always going to come out super nice. And also, it's not always necessarily given, not always necessarily a given that the origin is going to be one of your points. It can make things a little bit trickier, but not really a whole lot. I'm going to do my best to erase this cleanly. The idea is that whatever 2 points that you're given, whatever 2 points that you're asked to start off with, you can find a right triangle. And you can use the graph, of course, but you could also just think about things in terms of distances. So we'll actually do this in both ways. Okay. Here's my y-axis. There's my x-axis. And the points that I want to look at now are negative 4, 3, negative 4, 3, and 2, negative 1. So I can start by graphing it. Negative 4, 3, 1, 2, 3, 4, 1, 2, 3. It's right there. So that's A, point A, negative 4, 3. And then 2, negative 1 is over 1, 2, and then down to 1. So 2, this is point B, which is 2, negative 1. And I want to find the length of that line. Well, this will work in exactly the same way. I have a diagonal line. I'm going to find the right triangle. When you have the graph such as this, it's super easy. You can just count. It goes down 1, 2, 3, 4. And over 1, 2, 3, 4, 5, 6. So when I go to use my Pythagorean theorem, I have 4 squared plus 6 squared equals c squared. So that's 16 plus 36 equals c squared. So that gives me 52 equals c squared. So that means c is equal to the square root of 52. Always check to make sure that it can simplify, because this then turns into, well, 52 is 4 times 13, so this turns into 2 times the square root of 13. I mentioned that you can do this without the graph. And you might already know how. Since, after all, finding these two lines are also what we would use if we were wanting to find the slope, although I would call that -4 since it is going down. And it actually doesn't matter if we call it -4 or not. If I'm squaring it, I'm still going to get a positive 16. What this means then is that if you remember how to find slope without the actual graph, if you remember making a little table, for example, so of the x and y coordinates. So we had -4, 3, and 2, -1. We could just find the change in y, the change in y going down 4. We could find the change in x, the change in x going up 6. And then instead of doing slope, which remember is m, which is change in y over change in x, so that would be -4 over 6, which is then -2 over 3. Instead of doing that, because I don't actually want that, I'm going to use distance. So distance equals essentially the square root of the change in y squared plus the change in x squared. Figure out what the change in y is, figure out what the change in x is, and that's your formula. Really, this is just an application again of the Pythagorean theorem. Think in terms of the Pythagorean theorem. Draw yourself a picture, make the Pythagorean theorem, simplify it that way. If you like formulas though, that way will work too.